still common for subcontractors and engineering departments, production engineering departments, to receive data in a 2D format. Particularly for a subcontractor, this can be a problem if the allowances used, etc., on the blank are not correct. Fortunately, within the Radan system, we have a ability to import a DXF file and then convert that DXF file with the bend lines into a 3D model. So first thing I need to do is, I've got my blank here from the customer. I have to input the thickness, etc., because that can't be read from the model. Just say OK to that. I'm just going to use this to check the dimensions of the part. That just checks the integrity of the geometry there, and that all seems to be OK. So now what I'm going to do is I'm going to use the fold up from flat option within the part editor. So the next, and in here you can put information about that part. So we know that the geometry is in, the outer geometry is in pen 3, and we know that the up and down bends are in various different pens. Once you've got that information, you actually store it in a template, so the next time you receive a part from that particular customer, that will come straight to hand. Okay, it's going to look for R equals to find a radius, and it's look for A equals to find an angle. Say next. Okay, bend allowance, or fix that setback, or setback at 90 degrees. Now, this is obviously important because we need to recreate the part as it was designed. So we need to know what allowances or neutral axes they were created to start with. With that information to hand, I know that they were using 0.3 perhaps for that part. I'll put that in there. Bend radius, it's going to read the bend radius already because we've told it, but if it doesn't, we'll say put a bend radius and 5 in as the default bend radius. So I'll say next, and that's now scanned that model and picked up the different bends in that model. Next thing I'm going to do is go into the 3D environment. So it's finished that. I'll go into 3D. Just asking me, do I want to save the original blank there? Well, I don't really, because that information, I'm not happy that it is correct information. So here in 3D is the part. I can then edit that part, and I can change any information about this part because it is a fully associative Radan 3D model. So what do I want to do? I want to perhaps change the bend allowance, or perhaps change the bend radius. So if I zoom in here, let's just change the bend radius of that model to 2. And you'll see there, the radius instantly changed to 2. Let's just undo that. We're going to keep the radius as it is. We might also want to modify the part. So this is designed to be flood welded in there. Okay, we're not going to do that. We've asked if we could put a rivet in there. Does it need to be that strong? And they're happy for a rivet to go in there. So all I need to do now is edit this face on the blank, so that feature there, and I can go into a 2D view mode of that feature, and I can also view it with the rest of the model. Now that's viewed with hidden line at the moment, so what I'll do is I'll switch that to wireframe. Okay, so I can see those holes cutting through that face. So what I'll do is copy those holes, so I'll just parallel that hole there and that hole there. Okay, press apply, and I now have the holes straight through that part. Okay, what I'll do now is take that into the press brake software. So again, just pick a face on that part just to check whether we've got the tooling to produce this part. Again, as the press brake module starts, it's going to be looking for a bend sequence, and it's going to be trying to analyze the model for bend radiuses and look for suitable tooling to match that bend radius. So here is the part in the press brake module. Our bend sequence. I'm going to select machine. Select my tooling. And select my back gauge positions. And you'll notice on the tool rail there's a green piece of tooling on the upper tool. Now this is because the system has detected that there would be a clash and has automatically chosen a heel tool for the job. And again, in this mode you can step through the bends and see what's going on, and you can change anything at any time. So you might say, I want to change the offset of the bend. And that's all fully changeable. So you have a manual override if you want to at any stage. You can slide finger stops, move finger stops, etc. If I wanted to move that finger stop, I can move the Z-axis and I can slide that along. I can move it back again. Okay. Once I'm happy with that, I obviously need to check the simulation to make sure that there aren't any clashes with that part. And again, here it's chosen quite a wide V, so I get the radius that I required, which was a 5 mm design radius on the 1.6 material. And if you watch this last bend closely, you'll watch the overbend into the spring back angle. So if there were any collisions during spring back, that would be reported and taken into consideration. If there are collisions, you are given the option to either acknowledge them, which means you're going to go back and fix them, or you're saying, ignore them please, because I still want to produce the program. So press compile and you have a program for that part. So now I've created that, I'm going to create a blank for that part. So I can add a development. Let's just pick on a face of that part. So just pick on any face really. We go from there. And we use a development specific allowance. Smooth over. Apply. So here's my blank. And I can move that blank around if I wish. So what I'm going to do is go into there, define position, or alternatively I can rotate that to say 90 degrees, put that down there. So, what I can also do with the Radan system is create some views of the part ready for the production. So let's just apply that and define position. Let's just pop this over here and create a drawing for it. Apply. So now what I'm going to do is create a scene. So I want to add some elevations. So here we got some third angle, plan, front and right elevations. Let's just define those positions. So we'll have them there and there. Press apply. So now I've got some elevations of that part. We might also want to add a 3D view of the part as well. So here we've got an isometric view. Define the position of that. Let's put that in there. And press apply. Okay, so now what you're probably going to do is add some dimensions for the production guys. So let's put some dimensions on here and we can add this information. And we might want to put some dimensions on the blank as well. Etc. So now we've got ourselves a production drawing and a blank ready for production. Let's just save this. There's import. So finally, what I might want to do is open a project. So if we just take the project with the nest project, so here we have a current nest project. So what I'm going to say is, let's have a look at this one here. So we've got some space on there. What I'm going to do is drag our part into this nest, and you can actually bump nest this part, just push it where you want. What I'll do is I'll say to the system, actually I'll let you do this. Can you fill a window that big with those parts? Now that will do. That's running the nester now just to see, to pop those parts onto there. Okay, so now we've got some of those parts on the sheet. I might also decide that I want some more of these brackets here. And I can do the same thing. I can do a window. So let's see if we can fit any in that area there. I'm just going to go away and search to see if it can put in those parts there. And you can see there, we've fitted those parts in there. And it's warning me about this part now, saying on this project that currently nested, we've got 13 now. So we've actually got the amount required after 25, and we've got an overproduction of 13. So we have 38 altogether. Again, let's drag this part in, and we can put some of them down as well. And finally, some more of these brackets because we know that they fit in there. Let's just fill the rest of the sheet with those brackets, and that's going to search around and find. And there you go. And that job is now ready for production.